Alright, the last equation, I'm gonna try to do this. This is a little bit tougher. The last equation is called the time-independent kinematic equation. What we're going to do is we're going to take equation number 2 and equation number 3 and eliminate time from my equation. So in order to do that, I'm going to have to solve for time in one of those two equations and then substitute it into the other. We're going to choose solving for time for the top one. The reason why we're going to do this is because time is only in one of my terms. It's in this AT term. Where in this equation, time is in this term and in this term. It's going to make it much more harder to solve for. So we're going to use this top equation to solve for time. So I have V final is equal to V initial plus acceleration times time. To solve that equation, step 1, what we do is we isolate the term that carries the variable that we're trying to solve for. So anything that's separated by equal signs and plus signs and minus signs are referred to as terms. We have a term here. This V final is its own term. This V initial is its own term. This AT is its own term. Now inside those terms there may be variables. V final is a variable. V initial is a variable. And acceleration is a variable, and time is a variable. So I have a total of 3 terms, but 1, 2, 3, 4 variables. Okay? So step 1, isolate the term that has the variable you're trying to solve for. That would be, we're going to isolate AT. So what I'm going to do, first step, is I'm going to subtract V initial. In order to do that, I have to do it to both sides. Okay? So that translates into V final minus V initial equals AT. This cancels out and that one just travels over to the other side. Okay? So V final minus V initial is equal to AT. Now, solving for acceleration, well, I've already completed step 1. I've isolated this term. It's all by itself on this side of the equal sign. That's what I mean by isolating it. It's all by itself. Now, to isolate the variable, we go to the division and the multiplication process. To isolate that variable, I'm going to divide both sides, or not variable, yeah, variable. I'm going to divide both sides by acceleration. Okay? Cool. That means that acceleration over acceleration gives me 1, which we really don't care for. We don't keep track of 1s very often. And we're left with V final minus V initial over acceleration is equal to time. Okay? That's the first step in this process, is just to simply solve for time. I'm going to go ahead and write that over there. It's not an equation that you really have to concern yourself with. You can derive it whenever you need it. But I'm going to go ahead and put it over there anyway, because I'm going to need it for the next part. Okay? That's step 1. Step 2, what we're going to do is we're going to substitute this into here. This t is equal to this, so every time I see a t, I'm going to bring in this equation right here. So that means that I have, x final is equal to x initial plus v initial times v final minus v initial over a. Okay, just substitute it in for time, plus, here's where it gets really big, 1/2 a times v final minus v initial over a squared. Next thing I'm going to do is I'm going to FOIL this out. I'm going to move this square root around so I can simplify this a little bit better. So that means I get x final is equal to x initial plus, didn't change this one at all. I will in a second, but I'm not going to do it right now, over a plus 1/2 A. Now to FOIL this out, that's first, inside, outside, last. You can do it on your own. I suggest you do it on your own, but I'm just going to give you the answer. The first is I'm going to end up with V final squared. This times this, which is going to give me a negative V final V initial. This times that, which gives me a negative V initial V final. And then this squared. Whoof! All that over A squared. Okay? Simplifying that last big ugly part, I get xf is equal to xi plus vi vf minus vi divided by A plus 1/2 A over A squared. I just take that A and moved it underneath there, times V final squared minus 2 V final V initial plus V initial squared. Hoof. Cool? We see right here. Okay. Going to bring this inside. Cool. So what I have on the bottom is x final is equal to x initial plus this garbage. Vi times Vf minus Vi squared divided by A, not a pretty term, plus 1/2 times 1 over A times V final squared minus 2V final Vi plus Vi squared. Cool? That's where we are right now. It's not pretty. It's going to simplify, but it's not pretty. Okay, I went ahead and rewrote it on the top because I need the extra room. What I'm going to do next is I'm going to move a couple of things around to make my life a little easier. First thing I'm going to do is move this over to there. That's going to give me x final minus x initial. Okay? If we remember from our definitions, and I'll click on it really quick, that's displacement. Okay? The change in an object's position is the displacement of that object. So I'm just going to replace this with a D to make my life easier. Okay? So I move that over to the other side, and I'm left with this 1 over A that's floating around times this V initial V final minus V initial squared plus this 1/2 1 over A Whew. That doesn't look like it really simplified anything anymore, but it does give me the next thing I want to do. Look, I have A here and A here. Let's move it over to the other side. That'll start making things look a little more smoother. Okay? So boom, boom, moving the A over to the other side. I get acceleration times displacement is equal to V initial times V final minus V initial squared plus 1/2 V final minus 2 V final V initial plus V initial squared. Okay? I hate this. this 1/2. So I'm going to get rid of it. What I'm going to do is I'm going to multiply everything by 2. So that gives me 2 times AD equals 2 V initial V final minus 2 V final plus V final squared minus 2 V final V initial plus V initial squared. Cool? It's actually looking a lot better. What ends up happening is that this goes away with this. Okay? So that leaves me, and do I have room? Yeah, I have room. 2 times the acceleration times the displacement is equal to, I'm going to combine like terms, V final squared minus 2V initial squared plus V initial squared. Well, 2x minus, or negative 2x plus 1x gives me negative 1x. So this x that I'm talking about, I'm actually referring to this velocity initial squared. This is a variable. Whether it's squared or not, it's just a variable. So that translates into two times the acceleration times the displacement is equal to V final squared minus V initial squared. Wow, a lot of crap to get to that very end. What I'm going to do is I'm going to write that down right over here. So 2 times the acceleration times the displacement is equal to V final squared minus V initial squared. That's the time independent. Kinematic equation. Okay, a lot of mathematics just to get to it. It's nice practice to do it, but the fact of the matter is I've already done it for you. If you want to go back and check yourself to see how it was done, feel free to do so. I strongly recommend it. It doesn't hurt to improve your mathematics skills. But the end result is what we got here. Okay? Thank you.